What's up, YouTube? Haha, Mr. Robinson here. Let's get straight into the action here with a brand new, exciting video on angle relationships and parallel lines. In this video, we're going to go over several different concepts here. Now, there's a lot of vocab here and things to write down. If you are taking any sort of notes, I recommend that you pause at certain times to do so, just so you can follow along. My goal is to not linger on any one particular subject at any time, so just to kind of get through all the action in here, we're going to start with two things here. We're going to start with basic angle relationships, and alongside that, one of the relationship names that we're going to cover are vertical angles and linear pairs, and then I'll do some examples. And then we're going to look at lines cut by a transversal just by the names of them, and then we'll see what happens when those lines actually happen to be parallel as well. All right, now there are some new vocab probably right here for some of you guys. Vertical angles, linear pairs, and transversal. Maybe even parallel lines. Actually, I'm not defining parallel lines, but let's jump straight into it. Actually, do I? I can't remember. Okay, guys. Here's some vocab. Let's just look at the green and the blue right now to start with. What are adjacent angles? Adjacent angles are angles that share a common side and a common vertex. So right here, divided right here. This isn't necessarily bisected, by the way. These aren't bisected angles necessarily, but this angle and this angle, they are adjacent to one another in that they share this common side right here, and they share this common vertex. These two angles right here are not adjacent angles. They don't share a common side or common vertex, right? There are different things that we can say that are adjacent or non-adjacent, but when you see the word adjacent, I want you to know that they're next to each other. All right, what are congruent angles? Congruent angles are angles that are equal in both size and shape. I can say this angle is congruent to say this angle right here. Boom, boom, with the tick marks. Maybe they're both 100 degrees, something like that. You know, congruency. They're equal. When you have congruent angles, you can set their measures equal to each other. That's the goal. Complementary angles, I'll let you know what. We're not going to talk about complementary angles here in this video today, as far as like there won't be examples with them, but because we have supplementary right there, I think it's important to kind of just say both. So complementary angles are angles whose measures sum to 90 degrees. So if I have a 90 degree angle and it was like split into two like this, and if this was x and y degrees, x plus y is 90 because they add up. These are adjacent angles that add up to 90 right there. Therefore, x and y are complementary to each other. They're complementary. Now, I want to note right now, and this is going to be true for supplementary as well, you don't have to have adjacent angles for them to be complementary. I could have another x that looks like this right here, and then a y, that looks like this right here. They don't have to be adjacent to each other to add to 90, or excuse me, to be complementary. Just so you're aware. Now, that this isn't necessarily important for us for complementary, but today, supplementary, it will be important. Supplementary angles are any pair of angles whose measures sum to 180 degrees. So if I have, say, a straight angle like this that's broken up right here in some x and y, that is an example where x plus y equals 180 degrees. This is actually an example, guys, of a linear pair right here. I'll redraw this when we see linear pair again, but these are adjacent and supplementary. So here are supplementary angles. Now, just like complementary angles, guys, they do not have to be adjacent to be supplementary. We're going to see an example of something maybe that looks like this right here, where maybe this angle and this angle, maybe this is your x and y, these might add to 180 degrees as well. We're going to see that when we talk about the lines cut by a transversal. So these x plus y equals 180, they are still supplementary, guys, when that happens. So just so you're aware, they do not have to be adjacent to be supplementary. All right, here are two new vocab terms right here, linear pair and vertical angles. Now, I just drew an example of a linear pair, so let's do that again. If you have what's called a straight angle. You might call this a straight line, but there's a point, boom, now it's a 180 degree angle, right? When you have a straight angle that has two adjacent angles kind of formed within, again, x and y, you have what's called a linear pair. They are adjacent and they are supplementary, therefore they're a linear pair. All linear pairs are supplementary. Boom. Now, again, they have to be adjacent, they have to be supplementary. Boom, they're a linear pair. You could extend this line, and this is still a linear pair right here, right? In fact, I could get another linear pair right here with these two angles, or I could get another linear pair with these two angles. Anyway, I said I wouldn't linger. I won't. But we're going to do some examples with linear pairs. Basically, add them up to 180, because with the straight angle and them being adjacent, that'll be the nature. Now, there's this thing called vertical angles as well. If I have two lines that intersect, like these two right here, vertical angles are the angles that are opposite each other. So say this angle with this angle, if I call this x and y, those two are called vertical angles. Now, something about vertical angles, guys, all of them are congruent to each other. So basically, x equals y in this instance right here. Now, why do they call them vertical angles? I don't really know. I mean, you could say, well, look, these go up and down of each other. That may be true, but you know what? These are also vertical angles right here, the ones that are left and right, because they're opposite each other. So these are also vertical angles right there. And if this is x and y, x also equals y here, guys. The angles are congruent, so their measures are equal. So these don't go up and down of each other unless I rotate the object. So maybe that's why they call them that. But again, opposite each other when two lines are formed. Again, when two lines are formed right here, these are vertical angles and they are congruent. I'll let you know right now, again, I don't plan on lingering, but this is not an example of vertical angles right here, this x and y, because even though they're opposite each other, guys, these are not two lines formed. Those are bent, if you will. So anyway, vertical angles would form like that. So let's look at examples, guys, just to keep moving along. Let's look at examples of linear pairs and vertical angles right here in this next set. Let's find the measure of each unknown angle. Right here, two lines are formed. These angles are opposite each other right here. That B measure is 54 degrees because all vertical angles are congruent to each other. And that's what B would be. Here's an example of a linear pair right here, and this is 36 degrees. These are not congruent, but they are supplementary. So what I'm going to do is I'm going to say that 36 plus B, the unknown, equals 180. And if I subtract 36 from both sides, I'm going to get B equals 144 degrees. So that is the unknown angle B, because in a linear pair, angles are supplementary. Those are straightforward ones. Let's do ones that are algebraic in nature now. So I'm going to move on to the next page. Find the value of x with this information involved. And again, these are simple diagrams. They can get a lot more complex based on what you see. We're going to see more complex diagrams after this. Not necessarily with linear pairs and vertical angles, but we might. So, okay, here we have, once again, they measure this one, 2x plus 1 is that angle right here. This is 75. These are, once again, vertical angles, and vertical angles are congruent. So I should set these two equal to each other. 2x plus 1 equals 75 right there. Subtract 1 from both sides and divide both sides by 2. We get x equals 37. Okay, like I said, I don't plan on lingering. My goal is to set up the geometry part. I assume you know the algebra within. I'll say it out loud and I'll write it down, but no lingering. Okay, we have, another linear pair here. And these ones will add to 180 degrees. Once again, this is a straight angle, and these are adjacent. So I use the, I'm using the angle addition postulate, right? They just don't tell you that this is 180 degrees. That's something you kind of have to know because it's a straight line. Anyway, so these two sets add to 180. If I combine like terms, I have the 18 plus 130. That gives me 148. And if I if I subtract 148 from both sides, I'm going to get x equals 32. So, guys, with all that vocab that we saw so far, we see things that are congruent, we see things that are supplementary, we see adjacent angles. The only thing we're not seeing here are complementary, right? Nothing complementary, but we see vertical angles and linear pairs, and that checks off what we've seen so far. Basic angle relationships, complementary, supplementary, congruent, things that are adjacent, and we saw vertical angles and linear pairs. Now let's look at this part here, guys, and like I said, we're going to get a lot more vocab. We're going to get a lot more vocab. This is going to get to the nitty-gritty. Let's look at lines cut by a transversal, and then we'll see what kind of things happen when those lines actually happen to be parallel. Well, let's start with what a transversal is, and we're going to look at this diagram to help us out, guys. A transversal is like this red line right here, this red line T. A transversal is any line that intersects two coplanar lines at two distinct points. A lot of weird words basically on a flat surface like a piece of paper, like your computer screen, like or your phone screen or whatever you're watching this on. Those are coplanar lines. This line intersects this line and this line at two distinct points, meaning at two different points. Right? We're not looking at a transversal that's intersecting lines. Right. If this intersects these two lines here, but they intersect at the same place, that's no longer acting as the transversal that we want. It's not intersecting at two unique places, two distinct places. It's intersecting at the same place. Not really what we're talking about. We're talking about here, intersecting here and here. Anyway, so T is called a transversal because it intersects these two lines at those places. These lines are called L and M. When you have two lines cut by a transversal, you get certain angle relationship names. Now the first two guys, linear pair and vertical angles, I want to show you that these still exist in this set regardless of two lines cut by a transversal or not. So here comes a lot of writing from me with these angles A, B, C, D, E, F, G, and H. Let's see which relationships exist. Let's start with the two that we've already seen, and then we'll talk about what all these terms mean down here. Okay, guys, a linear pair, we saw them. A linear pair exists from a straight angle and two adjacent angles right there. So example, A and B right here. I'm not marking these congruent, guys. I'm just signifying what they are. A and B are an example of a linear pair right there. Now, I'm not going to write all these down. I'm just going to give an example. Angle A and angle B are a linear pair. Angle B and angle D are a linear pair, right? Angle B and angle D. This can keep going all around this thing here. A and B, B and D, D and C, C and A, right? This keeps going in that sort of way. Even down here you get some linear pairs. Look at G and H. Angle G and angle H are linear pairs. So like I said, it does keep moving along. You can write down as many as you want, but any set from intersecting lines right there that create a straight angle and they're adjacent give you linear pairs. Vertical angles are kind of in that same mind frame where when you have two intersecting lines such as these two, any angles opposite each other like these are vertical angles. So angle B and angle C are vertical angles. Can you guys name a pair of vertical angles here? How about in the other diagram right here? Which of these would be vertical angles? E and H would be vertical angles. Angle E and angle H because they're opposite each other, right? So anyway, I've talked about vertical angles and stuff before. My point is that even when you have two lines and stuff like that, you can still see linear pairs and vertical angles. They're still there. And linear pairs are still supplementary and vertical angles are still congruent. All right, guys, but here are the new terms. I got corresponding angles, alternate interior and alternate exterior angles, and same side interior and same side exterior angles. And like I said, my goal here is not to linger. So I'll try and do the best I can with what I have as fast as possible. I'm not defining these, they're not typed as being defined, so see if you can follow along. Corresponding angles, which is kind of unfortunate because we've seen the word corresponding as far as corresponding parts, corresponding sides, and angles and diagrams. So this is used again here. But corresponding angles, guys, are angles that when you have, again, this is about two lines cut by a transversal. They're angles that, well, they face the same direction. So these ones here, like F and B, you see angles F and B right there? These are corresponding angles because when these two lines are here, they face the same direction. We have angle F and angle B right here. Those are corresponding. There are four pairs of corresponding angles here. I'm not going to write them all down, but I'll give you another example. Angle C and angle G. These are corresponding angles right here. They face the same direction within these bits. They kind of belong within that same molding and group just because of the way that they're there. Now, we're going to get into more with this when angles are, or when lines are parallel and how corresponding angles relate. But for now, those are corresponding angles. Here's another set. A and E are corresponding angles. And then D and H. I'm trying to undo. D and H are also corresponding angles. Okay. Okay, alternate interior angles, alternate exterior angles. Here's where the transversal comes into play, guys. The transversal shows these letters on one side and these letters on the other side. When you use alternate interior and alternate exterior, the word alternate means on opposite sides of the transversal. So these are examples of alternate angles, not alternate interior though. Alternate interior angles are angles that are within the interior right here, and alternate meaning on opposite sides of the transversal. So angle C and angle F are examples of alternate interior angles right here. They are on opposite sides of the transversal, and they are inside the two lines here. Angles E and D are also alternate interior angles with one another. These are angle pairs. Everything we're talking about are angle pairs here. Even supplementary and complementary angles are angle pairs. Let's look at alternate exterior angles. The same deal, only now they're on opposite sides of the transversal, only now they're going to be outside of your two lines that are cut by the transversal. So here's an example of alternate exterior angles, A and H. They're on opposite sides of the transversal, and they're outside of those lines. So angle A and angle H are alternate exterior angles. What's another set of alternate exterior angles? B and G. Angle B and angle G are also alternate exterior angles, again by nature opposite sides of the transversal outside the lines. Well, if alternate means on opposite sides of the transversal, same side must mean on the same side of the transversal, and we still have interior and exterior like before. So what would same side interior be? Same side interior would be inside the lines right here and on the same side of the transversal, like angles D and F. And what's another example of same side interior? C and E. Angle C and angle E. Okay. Last set right here. Let's find some same side exterior outside the lines and on the same side of the transversal. Angle A and angle G are same side exterior angles. And then angle B and angle H are also same side exterior. So guys, a lot of new terms here. 7 new terms from all these, which can all be, and I didn't write all the linear pairs and vertical angles. I did, and I didn't write all the corresponding angles. I did write all the alternate interior, exterior, and same side interior, exterior, however. And so here's the thing, guys. There are special angle pair relationships, such as these here, but these lines weren't parallel. Notice that even when the lines weren't parallel, these names still exist. The names still exist. There's something super special about these when these lines are parallel, though, and that's what we're about to look at next. So those are those names, guys, when we have lines cut by transversal. What happens when those lines are parallel? What can we do? Well, when lines L and M are parallel and this transversal T intersects those lines, guys, the A, B, C, D, and E, F, G, H stuff, all these things, they now have very special things that happen to them, special properties. And they can be proven. We're not going to do proofs. I can already see that my time's running up a little bit here. But we have something called the corresponding angles postulate. This word postulate just means something we can accept as truth. And here's what it says. If a transversal intersects two parallel lines, if T intersects these two lines that are parallel, by the way, these are signifying parallel lines here, the arrows, then their corresponding angles are congruent. So hey guys, what's an example of corresponding angles? Remember B and F? These are corresponding angles right here. Did you know that when these lines are parallel, the corresponding angles are congruent to each other? Yeah, angle B is congruent to angle F now, when lines are parallel. Before, if I go back, this B and F right here, these lines were not, they weren't parallel, or at least we didn't know them to be parallel. These angles weren't congruent at the time. Now they are. And it's called a postulate for the corresponding angles one, guys, because how can this not be congruent to this? They are literally the same angle. All I got to do is translate this thing up into there. I don't have to rotate or reflect it or anything. It's the same angle because it follows the transversal, And a parallel line means there's no way it can't be the same angle, right? So that's a postulate. Based off the corresponding angles postulate, you could prove these other things. The alternate interior angles theorem, the alternate exterior angles theorem states this. When a transversal intersects two parallel lines, alternate interior angles are congruent and alternate exterior angles are congruent. Let's do one at a time. Alternate interior angles. Check out C and F, guys. These are alternate interior angles. These are congruent to each other. Notice how they kind of both look acute together. Oh, they look so acute together. Notice how they're kind of acute angles right here. It's kind of easier to tell which ones will be congruent versus other ones that will be supplementary by saying, are they both acute or are they both obtuse, or is one acute, one obtuse, things like that. Anyway, these are congruent to each other only when lines are parallel. Only when lines are parallel. Now, here's a quick proof of this. I'm not going to write out a proof. I'm just going to diagram it. You guys remember how corresponding angles were congruent, right? Remember how vertical angles were congruent? Well, if angle F is congruent to angle B, and if angle B is congruent to angle C, that must mean angle F is congruent to angle C. That is what's called the transitive property of congruence. And if you saw my last video, then you know what transitive property is probably a little bit about. If F equals B and B equals C, then F equals C. So it can be proven as long as you understand the corresponding angles postulate. Anyway, guys, alternate interior angles are congruent. What about alternate exterior angles? Look at A and H. Here's an example of two rather obtuse angles. Again, lines are parallel. Alternate exterior angles are congruent. This stuff, what this is going to help us do, guys, just like the linear pair and vertical angles things, is when we have measures on the outside, we know we can set them equal to each other because they're congruent. So, corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Surely that must mean same side interior and exterior angles are congruent as well, right? Not quite. Actually, if a transversal intersects those two lines, those are supplementary. So let's look at same side interior angles. Let's look at D and F here. By the way, again, when I'm doing these marks, I'm not marking them congruent. In fact, if it helps, I'm going to go ahead and do a double arc mark here. D and F are supplementary to each other. Not congruent, but supplementary. They add to 180 degrees. You can tell how one is kind of obtuse looking, one's kind of acute looking. I don't think there's a reason to think that they are congruent to each other, no. How would I prove something like this? Well, remember how corresponding angles are congruent? That means that D and H, which are corresponding angles, by the way, right? D and H are corresponding angles. They're equal. You know what F and H are? They're a linear pair. You know what we know about a linear pair? They're supplementary. So if D equals H, and if H plus F adds to 180, then D plus F adds to 180, right? That's kind of a substitution right there. D equals H, D can take H's place. So these add to 180, I guess these two as well. So hey, remember, they don't have to be adjacent to be supplementary, like these same side interior angles right here. These are not adjacent. How about same side exterior angles? Let's look at A and G. A and G also supplementary. Same kind of thing as before. So I'm going to write these on the next slide. But anyway, all the diagrams are there. Here are the theorems. Again, they can be proven. Let's go ahead and write these things down. So linear pair, not congruent. Linear pairs, guys, they are supplementary. Vertical angles, they are congruent. Corresponding angles are congruent. By the way, these bottom ones need lines to be parallel for this information to be true. These top two ones, they don't need lines to be parallel because they don't need two lines cut by a transversal. They just need some form of intersecting lines. But these bottom ones, corresponding angles, alternate, whatever, you need parallel lines for these to be true. So when lines are parallel, corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. Basically, I can say, I said it before, angle B is congruent to angle F for corresponding angles, things like that. Same side interior angles are supplementary when lines are parallel, and same side exterior angles are supplementary when lines are parallel. Almost done. I got a few examples and then that's it. So let's take a look at the examples here. Let's find the measure of the unknown angle in this diagram. Now, you need these arrows to indicate that the lines are parallel for us to do anything that we want to do here regarding any of that bottom set. If this was vertical angles or linear pairs, we don't need parallel lines. But here we do. We need to know this angle right here. Well, 120 degrees is measured right here. And this has a certain relationship with this. What is that relationship? These are on opposite sides of the transversal. These are outside of the two parallel lines. These are alternate exterior angles. And alternate exterior angles are congruent when lines are parallel. So you know how much this is right here? It's 120 degrees because this is 120 degrees. So that is the measure of the unknown angle. There's that one. Let's do this example over here. Solve for x in the below diagram. So in this below diagram right here, we have two measured angles, one with x in it, another 125 degrees. The lines are parallel, so we can play with those, we can play with those relationship things, right? These two, what are these ones name-wise? They are on the same side of the transversal, and they are inside the parallel lines. These are called same side interior angles. And when lines are parallel, what are same side interior angles? Are they congruent or supplementary? They are supplementary. So when they're supplementary, I don't set them equal to each other. I add them to 180. So 15 plus 5x plus 125 equals 180, just like I would with a linear pair. This is just like a linear pair thing. Anyway, combine like terms. Subtract 140 from both sides, and then divide both sides by 5. You get x equals 8. Again, kind of skipping the algebra there. One more example, and then I'm done. I'm going to finish before a half hour. I feel good about that. Last one, find the measure of the bold angle by solving for x. So once I find out what x is, I'm going to be able to substitute that value into here to then find out what this whole angle is. Okay, so let's go ahead and do that. So what kinds of angles are these? They're on the same side of the transversal, but one's in the interior, one's in the exterior. What do you call that? Well, it doesn't have a name with same side in it. Remember the ones that kind of face the same direction? It's kind of like they correspond with each other. Yes. These are called corresponding angles. And corresponding angles are congruent when lines are parallel. So you know what I do with these? I set these equal to each other. I set these equal to each other. Now let's go ahead and solve for x. I'm going to subtract 9x from both sides. I'm going to add 3 to both sides. I'm going to divide both sides by 2. I get x equals 10. Am I done? Not quite. I got to find the measure of the bold angle here. I solved for x. Now let's find out what that bold angle is. Let's continue that arrow. This bold angle here is 11 times 10 minus 3. That's 110 minus 3, which is 107 degrees. And you know what? If I substitute 10 into here, I get 90 plus 17. That's also 107 degrees. They should be. These angles are congruent. Only when the lines are parallel, these angles are congruent. So, case in point, guys, like I said, I wasn't using complementary here, not angles that add to 90. It's a term to know. But all the angles within the parallel lines cut by a transversal will either be congruent or supplementary. And you'll kind of be able to tell kind of based on, hey, are they like acute or obtuse, like that. But once you know the angles by name, or if you wrote them down, you can kind of get them done that way. And here's some of the math that does it. So we covered everything, guys. We got some of the vocab out of the way, and we could talk about vertical angles and linear pairs. Not always with two lines cut by a transversal, by the way. We didn't do any examples with two lines cut by a transversal with those. And then we looked at lines cut by a transversal, and then when they were parallel, what happened? So again, the corresponding angles, alternate interior, exterior, same side interior, exterior. Which ones were congruent? The corresponding and alternates, and then the same sides were supplementary. That ought to do it for me, guys. This is Mr. Robinson here. Thank you so much for watching. Take care.